Hello everyone. Today we will start with the module 2 where it consists of measurement of force, torque and pressure. Okay. With the first topic we will start with the measurement of force. Before going to that, we should know what do we call it as force. So force is nothing but, if we go for the definition, force is defined as the reaction between two bodies. So that reaction may be a pulling force or it may be a pushing force. That means a tensile force or it may be a compressive force. In general term, we call the force is equal to its mass into its acceleration. So if it is in gravitational force, so we know what is acceleration due to gravity. Okay, so and with that, force is the unit of force is in Newton. Okay, so the measurement of force involves the determination of its magnitude as well as its direction. So coming to the next point, which are the measurement techniques we have to determine the force. Okay, so force can be measured by using two different methods, that is, one is direct method, another one is indirect method. Okay, so in direct method, generally in direct method it involves direct comparison with the known gravitational force on a standard mass. So this we generally you used to see this kind of direct comparison in your day-to-day life, where if you go to any normal grocery shop and all, they used to compare a standard weight, that may be half kg, 1 kg, 2 kg with the unknown quantity that you are going to buy. It may be a sugar, it may be a rice, it may be anything else. So that we call it as a physical balancing. So that we call it as a direct method. So for example, it is an analytical balance, that is equivalent. Generally we are using in a grocery shop. So coming to the indirect comparison method, so this involves a measurement of effect of force on a body. So some force that has been applied on a body, what is the effect? So that you are going to measure. So the example here we have the unequal arm balance and platform balance. You are going to know about this unequal arm balance and platform balance in the further slides. Okay, so let us start with the direct method, where we take it as analytical balance. It is equal arm balance. By looking at the figure, you got some basic idea what we call it as equal arm balance. So in this direct comparison of unknown force with the gravitational force can be explained with the help of an analytical balance. So in this, by looking at the figure, I think you got a good idea what is equal arm balance. Okay, so this is a schematic diagram where we use to understand the concept of equal arm balance. Okay, so in this, the direction of force is parallel to the gravitational force, hence only its magnitude needs to be determined. What is this direction of force is parallel to gravitational force? So here we have different weights W1 and W2, right? So before that, so this is an unbalanced pointer, equal arm balance. Okay, we can see here this is the balanced arm. Okay, presently it is in unbalanced condition. Okay. So here the balanced arm rotates about the point O. This is point O. Okay, so at both the ends we have the W1 and W2 as a two weights, whereas this W1 is an unknown weight and W2 is a known weight, that we can also call it as a standard weight. Okay, so this G, what we can see here is this is the center of gravity for a balance arm. Okay, this is the center of gravity for a balance arm, and WB is the weight of the balance arm. WB is the weight of the WP is the weight of the balancer. So, and here we can see also some notations as dB and dg. So this dB is the distance from the point O to the weight where that has been hinged. Okay, so and dg is the distance between the point O and the gravitational where the gravity is going to act. Okay, so and the L is the distance from the point O to the one end of the weight, that is W1, and another end of the weight W2. Okay, so let us start with so when, if consider here the weight, the unknown weight W1 is more than the standard weight, what happens? Automatically the arm balance will be towards the W. Due to this uneven balance, the pointer will move towards the right direction. During that time, it will provide an angle with the vertical axis, that is theta. Okay, so if W1 and W2 is equal, then the theta will be 0, right? So if W1 and W2 are different, we will get a theta angle due to the deflection of the pointer, right? So then we can go to the what is its sensitivity. So sensitivity of the balance is defined as the angular deflection per unit unbalance between the two weights, that is W1 and W2. So what is the sensitivity? So sensitivity is defined as the angular deflection per unit unbalance between two weights W1 and W2. That is the deflection that occurs due to the change in weight. Okay, so we can call it as, if a small change in weight with W1 and W2, if the deflection is larger, then we can call that as that particular weighing balance is having more sensitivity. If even for a larger change in weight, if we see a smaller deflection in that is pointer, that theta is very smaller, then we can say the sensitivity is very small. Okay, so this change in weight W1 and W2 we are denoting in delta W. Okay, so coming to this sensitivity can also be calculated by writing the moment equation at equilibrium as follows. Okay, so as we have learned all this moment equation in the third semester in MOM subject, so we can say W1 weight 1 is equal to into L cos theta minus dB sin theta, that is equal to W2 into L cos theta plus dB sin theta plus weight of the balance WB into dg into sin theta. Okay, so if the smaller deflection happens, then we can consider the sin theta is equal to theta and the cos theta is equal to 1. Okay, then the above equation will be sin theta will become theta and cos theta will becomes 1. W1 into L minus dB theta. In the same way, W2 L into 1 plus dB into theta. Sin theta will become theta. So in the same way, WB dg will be same and sin theta will be theta. So here we can see WL into L minus dB theta is equal to W2 L plus dB theta plus WB dg theta. So here we are multiplying with this W1 into L, W1 into dB theta. In the same way we are doing it the right hand side also. So in the next step we are bringing this W2L into the left hand side and we are taking this W1 dB theta into the right hand side. We got this equation. Then we are taking L as common and the other side we are taking W1 plus W2 as common. Okay, so from this we got theta is equal to W1 W2 into L, W1 plus W2 into dB plus WP into dG. So we know that sensitivity is equal to, we got theta, we know that sensitivity is equal to theta divided by its change in weight, that is W1 minus W2. So we are substituting this theta value to this particular equation. During this time we can cancel this W1 minus W2 from both numerator and the denominator. The left thing is L divided by W1 plus W2 into dB plus WB into dG. So in equilibrium condition we say that W1 and W2 is same, that is we can consider that as those are approximately equal to W. Then we can say that S is equal to theta divided by change in weight, that is delta W. So here W1 and W2 both will become W and W. W plus W will be 2W into dB plus WB into dG. So this is what the equation we got for sensitivity. Okay. So this sensitivity is main of the balance is independent of the weight that has been provided. In what condition this is independent of that? So if you reduce the length of this dG and dB, you can increase the sensitivity of the balanced arm. Okay, so in this condition we can say S is equal to L by WB into G. Okay, so here we are telling that if we decrease both dG and W, we can increase the sensitivity. At the same time, if we increase the length L, we can increase the sensitivity. Okay, so in this particular equal arm balance, what we have here is, so if you want to weigh any mass, any weight, so you should have the equal amount of weight which you need to, the standard weight should be equal to that of the required weight. So if you want to weight a heavier weight of around 50 kg, 100 kg, at the same time you should have a standard weight of 50 kg or 100 kg. So that is one of the major disadvantage of this unbalanced equal arm balance, that we call it as a direct method. So in order to overcome this problem, every time if we want to weigh 50 kg or 100 kg, we cannot keep a standard weight of 50 kg or 100 kg. In order to overcome this particular problem, we can go for unequal arm balance.